Algebra 1 half lesson 88. Greetings. We're going to end this week on a geometry note. We're going to talk about the surface area of a right solid. Ugh, that sounds so hard, doesn't it? But remember that a right solid just means a three-dimensional object with perfectly even sides. We've talked about cylinders up till now. Oh, mine is not what it should be. A right solid is like one of those oatmeal canisters where it's got perfectly straight sides, perfectly flat and even top and bottom. It's not like a soup can that has a funky little ridge and an indent. It's just perfectly straight. It's not like, like most soap dispensers, whether it's hand soap or like kitchen dishwashing soap that you use in the sink. You know how those are like not perfectly straight on the sides? They have indents or they have graduated sides like that. No, we're not dealing with anything weird. We're dealing with perfectly straight, perfectly even. An oatmeal canister is the best thing I can tell you. And we know surface area, that's a code name for our magic wrapping paper that covers everything without any overlap, right? And so we're measuring all the surfaces to see how much of our magic wrapping paper we need. And in order to do that, because it's a solid, that means it's a three-dimensional object, so we need our box cutters. All these shapes are made of cardboard, and we're going to cut them open and measure the shapes. And that's what we've done here, right? We've taken our box cutters and we've cut these open, and we've gotten a top and a bottom, and then that long body, we go, we cut it down there, and then we get a rectangle, right? So that's how we do top, bottom. These are the same, right? Because our thing's perfectly square. And then these are the sides, or what we call, in fancy talk, these are the lateral. What do they call these? Have we used that? Lateral surface area, which is just a fancy way of saying the sides. Okay? So that's what we've done in the past with our cylinders, and what we're going to do today is just experiment with some different shapes. The process is exactly the same. In some ways I think it's, but I'll explain that as we go. Example 88.1. Have you ever eaten Toblerone candy? I hope you have, because this shape is basically a Toblerone box. They've changed their packaging recently. I don't know if it's still like this, but it's a triangle full of chocolate. Come on, what's not to love about that, right? Okay, and so this is the picture that's on 88.8, and it says find the surface area of the right triangular solid shown. Dimensions are in meters. Okay, so now I'll copy the numbers. 4, 3, 5, and 16. Now the picture doesn't show it, but I know that down here, that's another triangle, isn't it? And then this is all connected by a crease. Maybe that can help you see the three-dimensional aspect of it. So, everything's straight and even, just like our oatmeal box, the Toblerone box. Look for that, which, I mean, that might not be soon, but you could always Google it too. It's perfectly straight and even. So, we get out our box cutters and we start cutting out the shapes. We're going to have one end and the other end, right? These two ends. And then we're going to have this long shape, and what I'm going to do is I'm going to cut it along this top edge and flatten it out, but it's going to have two folds in it, right? It's going to have this crease and it's going to have this crease. I'm cutting it right along there. You could pick any side to cut it on, but it's going to have two other fold lines on it because it was curved up as a tube. Alright, so that's what we've got. Now I'm out of space. I'm going to squeeze my calculations in here so that we can see the picture as I work. Let's start with the triangles, okay, the ends. I'll do that work here. We need to find the area of the triangle. Base times height divided by 2. I just taught Joel and JoJo this. a few minutes ago. All right, so that's the formula. Our base is 3. Our height is where the spider crawls. So it's not the 5, it's the 4. So it's 4 times 3 divided by 2. I can see that that means that each of these equals 6. That one's 6, and that one's 6. Make sense? So in the end, I'll add those up. Now we have to figure this thing out. Okay. This is 16. It's this dimension, right? These, let's see. I'm not sure how we want to orient them. 4 and 3 and 5 as the 3 sections of our folded main body area, right? So if we add these up, just a second, let me give us some room to work. So I'm going to call this the side. This whole thing is the side. That is going to be length times width, right? Because it's just a rectangle. And so these 3 sides are what's going down here. So 4 plus 3 is 7, plus 5 is 12. So I'm going to call that 12 times 16. You could argue that the 16 is the length and the 12 is the width. It doesn't matter. We're multiplying. What is that? Associative no, it's it's one of those properties we just talked about. We can write it in either order. It's fine. And we do that. And we get 16 times 12, which is 192. So that's how much this is, right? And so to find our total, it's going to be 6 plus 6 plus 192. I'm going to use one of those other crazy properties to change that in my head to 12. 12 plus 92 equals 204. These are meters, and we're finding area, so it's squared. 204 meters squared is the total surface area of our Toblerone box. Tobler, I wrote that wrong. Toblerone. Pretend it's right. And it would be written on here, Toblerone. Those are really good. I like those candies. And I like candy, but I'm not a candy freak. So when I find one that I like, you know it means something. Okay, so there's our total. This is one kind of shape that we can have. And again, the jam to this, Caleb, is to figure out the shapes you're going to get after you take your box cutter to this, and then remember all your different formulas for finding the areas. And the reason that I think these are easier than these is because here we have to find circles, and that involves pi and those crazy formulas that no one ever remembers. Triangles are way easier to find the dimensions on. Okay, so now we're going to make it harder. Sorry, that was an easy one. Now I'm going to make it harder on you. Example 88.2, and this is our last example for the day. Find the lateral surface area of a right solid 10 feet tall whose base is the figure shown on the left. All right, so let's look at what we've got. I'm going to draw the picture because that always helps me understand the problem better, plus it gives me something interesting to do besides just math. All right, so it's kind of like, I think it's kind of like a mailbox tipped on its side. Pretend that's not there. It looks like a mailbox tipped on its side to me. I've had students say it looks like a toilet with the seat down. I mean, okay, whatever floats your boat. This is the three-dimensional object. John told us that it's 10 feet tall. So this dimension is 10 feet, and we're working in feet. We don't need that until we get to the answer. Okay, then what John does is he gives us another picture that looks like this, and this is where the numbers are. So what he's done is he's taken this flat surface and he's given it to us in a top-down picture so that we can understand the dimensions of it better. All right, So we know that we're going to have, if we take our box cutters to this thing, we're going to have one of these kooky shapes, two of these kooky shapes, and then we're going to have this, we'll cut here, and this will become a rectangle. And it's going to be this big benty section, and then there will be one crease in it near the other end. All right, that just helps me understand what I'm looking at. Now we have the area of all these things. All right, and this one's going to be a little bit more of an ordeal because this is more complicated than a circle or a triangle, isn't it? So how do we find the area of this shape? Well, we can divide it into two smaller shapes. You're good at doing this. This is going to be a rectangle. It's not a square. What's the length of this side? Well, this radius is 3 and 3, so this must be 6. So the area of the rectangle is 6 times 8, which is 48. Notice that I'm using pictures of the shapes, right? I'm underneath here, and then I'm breaking this into shapes. I'm going to do the semicircle next, so it'll be like this. I'm drawing pictures and then writing the calculations over to the side, so I'm making a little table. Sometimes it's helpful to leave space for the formulas too. I didn't do it here, but I'm going to do it here. Now I need to find the area of this little semicircle part. The area of that is going to be pi r squared, that's the area of a half circle, divided by 2. All right, that's going to be, oh my gosh, it's going to be John laid out the answer. 0.14. R squared is 9. This is divided by 2. Right? 3.14 times 9 divided by 2. John, I have to back up. I've made this too complicated. John does not want us to find the entire surface area. He just wants us to find the lateral surface area. So, the moral of the story, Caleb, is make sure you read the directions before you do the problem, because I didn't read them carefully, and I was going to find the entire surface area, and that's not what John asked us to do. I was trying to check this calculation in my answer, and I was like, wait, it's not there, and then I realized, oh, I'm making this harder. So we don't need any of this. My bad. All we need is this part, okay? Just the lateral surface area. Lateral means side. Okay, so now we know this dimension is 10 feet, right? And this we're going to get by finding the perimeter of all of this. So the perimeter of that whole thing is going to be 8 plus 6 plus 8 plus the circumference of this, which is the circumference of a half circle, equals pi 2r, but because we only want a half circle, it's divided by 2, so it's going to be plus pi times the radius is 3 times 3.14. Okay, this much, I'm going to add the 8s together, that's 16 plus 6, so it's 22 plus, and then 3 times 3.14, I'll do that calculation here, 9.42, I can add that in my head, the 22 and the 9 are going to give me 31, and then the decimals just come along for the ride, and our unit is feet, and it's surface area, so that's a square. that. That's this area, or this length, right, is the 31.42. I have to multiply it by 10 because this is the length and this is the width, right? So it's, I just bumped the decimal over. See, I got excited and I stopped too soon. I thought I was done. That is one of the biggest problems with these problems. The biggest problem with these problems, Caleb, is they just keep going on, right? Okay, so all of this work to find the perimeter got us here. That was this dimension, and then we had to multiply it by this dimension of 10 in order to find the area of this whole lateral business. I'm sorry if I confused you. Hopefully you're smart enough to work past it. I know you are. Lesson 88 is now complete. Good job.